Today you are going to study chemical bonding. Before starting the chemical bonding, you must be understand about the electronegativity. The electronegativity is a measure of the tendency of an atom to attract a bonding pair of electrons. If the electronegativity of an atom is high, then it attract and hold on to electrons. If the electronegativity of an atom is low, then it tends to give electrons away. Electronegativity differences thus determine bond type and explain that is meant by polar bond and polar molecules. If the difference in electronegativity is between these points for ionic, polar covalent, non-polar covalent bond, example NaCl, Na.8 Cl3, difference is 2.2. So this is an ionic bond. You can better understand. Now, what is chemical bond? A bond is a link or force that binds two or a group of atoms together to form a compound. The type of bond found in bimolecular can be divided into two types: covalent bond and non-covalent bond, including hydrogen bonds, ionic bonds, hydrophobic bonds, van der Waals forces. You can also understand big bonds. Big bonds are bonds that form between different molecules or within different pairs of a large molecule, while these bonds are not strong enough to hold a molecule together. They are extremely important because of their large number. There are three basic types of big bonds: hydrogen bond, interactions, and van der Waals forces. You can see the hydrogen bond here through this picture. These are the secondary interactions and these are the covalent bond. You can see here again, these are the secondary interactions. Hydrogen bonds, what are they are? A special case of permanent dipole-dipole interaction. They are stronger than van der Waals forces. Basically, hydrogen bond is stronger than van der Waals forces and it is big bond as compared to covalent bond. Dipoles with hydrogen bonds have higher boiling points than molecules that don't. For hydrogen bonding, what do you need? A hydrogen atom covalently bonded to an electronegative atom such as nitrogen, oxygen, or fluorine means when a hydrogen atom is covalently bonded with a strong electronegative atom such as nitrogen, oxygen, or fluorine, then it is able to strongly attract the share pair of electron. That's why nitrogen atom acquires, oxygen atom acquires a partial negative charge and hydrogen atom acquires a partial positive charge. The particular negative end of the one molecule weakly interact the positive end of the another molecule, and that particular weak interaction is known as a hydrogen bond. If only one of these conditions is met, you do not get hydrogen bonding. Give me an example. I am taking another more example. You can consider methane. This does not have any hydrogen bonds. Carbon is not very electronegative and it has no lone pair of electron in methane. There is no any lone pair of electron and there is no more difference between electronegativity of carbon and hydrogen. You can take a real example. Ammonia. This one is ammonia. This is nitrogen, hydrogen, 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 and this is the simple lone pair of electron. Lone pair of electron. This does have hydrogen bonding. Nitrogen is very electronegativity and it has one lone pair of electron in ammonia. You can take another example. Water. These are the hydrogen. These are the oxygen and these are the lone pair of electron. This has not one but two hydrogen bonds. Oxygen is very electronegative and it has two lone pair of electrons in water. Remember, you need for hydrogen bonding always you need a hydrogen atom covalently bonded and electronegative atom such as nitrogen, oxygen or fluorine, a lone pair of electron on the electronegative atom. If only one of these conditions is met, you don't get hydrogen bonding. Now, you are going to study the ionic bond. Generally, chemists consider this to be strongest of all bonds as long as no water is present. In biological system, ionic bonds are weak due to this fact. Helium, neon and argon are atoms which do not react with the other atoms. We call them the inert gases, noble gases. Each of these gases has a full outer electron shell. You can easily see here through pictures. You can better understand about this. These are pictures showing helium, neon and argon and electrons with their shell. You can take example of sodium. It's 3 cells, atomic number 11. 11 protons, 12 neutrons and 11 electrons. Chlorine, 17 protons, 18 neutrons and 17 electrons. Sodium atom has one electron in its outer shell. You can see here 281. Sodium has lost one electron to leave a complete outer shell. It is a new sodium ion with a change of one electron. Sodium plus 28 ion. This one is plus charge. You can see here. Chlorine. This has 287. Total one electron to gain a complete outer shell. It is now a chlorine ion with charge of 1 minus charge. Chlorine 288, this one, and there is a formation of sodium chloride. So held together by strong electrostatic force, opposite charge attraction, high melting point and boiling point, regular structure, gain ionic lattice and melt or dissolve ionic compound, conduct electricity. Covalent bond. Chlorine atom sharing of two chlorine atom, electrons, force bonds between atoms in the molecule very strong. Molecular formation of ammonia and other molecule. Chlorine covalent bond. सेव करना. नीलेश सेव करना भी.